Good morning. Welcome to class. Well, today we're going to do something really exciting. So I want you to sit back, relax, and look at this video. Good, so the video was about two siblings, Anna and Andrew, and Anna was nervous because she had a test on, could somebody remind me the topic, something that we're on? Good, so electrolysis. Anna had a test on electrolysis and she was nervous, so her brother loaned her a copper coin. Good. What happened next? Alana? Very good. So next, well, Anna said the coin is magic. She aced her test. However, she lost the coin. So what is Anna's predicament and what is she asking us to help her do? So I'm seeing many hands. Very good that you are so active this morning. Okay, Mary. Great. So very good. Anna is hoping that we can help her get back a copper-plated coin for her. So how could we help Anna? That is what I want to know. Think about it and how could we help Anna? And I'll give you a couple clues. I want you to think back to yesterday's class. We spoke about how we purify copper metal. So we use a process of electrolysis. And before we did that, if you remember well, before we even spoke about the purification of the copper, we said that we can use electrolysis to do a couple things in industries, the industrial applications, and we mentioned the term. So let me see how much of us are paying attention. We mentioned the term yesterday, and then based on what we're seeing in the video, if we can say what's the process used to help Anna get back this copper-plated coin for her brother. So I'm saying we're thinking and seeing some whispers. Would anybody like to volunteer then? And yes, okay, so you want another clue. The word starts with E. Very good. So it's electroplating. Very good, ladies. So today, let me just call this slide. Alright, today we're going to talk about electroplating. And more so, what it is we want to do. Electroplating, we want to try and remind you what Anna wanted us to do. Copper plate. So we want to try and copper plate a coin for Anna. But how are we going to do this? Because we actually want to see if we can do it. So we want to try something here. And to help you out, I want us to look at this diagram from yesterday's class. So remember, yesterday we spoke about how we purify copper metal. So if you remember from the same diagram and the video we saw, we had an impure metal strip which is made of copper, and our cathode was a pure strip of copper. The anode ionized, gave up copper 2+, and that copper 2+ was deposited onto my cathode. So based on this and what we did yesterday, I want to ask you a couple questions. So the first question I want to ask you, and making reference again to this diagram, what do you think we can use as our anode today? Will we be using inert graphite as the anode, or will I be using copper metal as the anode? And again, taking in reference to the diagram here. So think about it. Right, Selena, could you help us out? Good job. So she is saying that we are going to use a strip of copper metal for our anode. Yes, very, very good. So now that we have that, what about the cathode? What is going to be used as our cathode? So again, what you all think? Based on these three things now, could we use graphite, another piece of copper, or the coin? Think about it and how, remember, we have to help Anna do something. So yes, I'm seeing people laughing. They say, well, yes, miss, if we're using the copper metal as anode, but then the coin has to be our cathode. Very, very good. Well done. So in front of you, you have an activity sheet and you have some apparatus and materials that Ms. Denise has put out for us. So we are going to try and set up an electrolytic cell to investigate if we can really copper plate this coin to help Anna. So when we were doing that, I know it's the first time we are setting up an electrolytic cell. I will come around and help you, and we're hoping to get a cell looking something like this. So remember, copper is your anode, the coin is our cathode, right? So I'm going to come around and help you. However, make sure, safety first, I want everybody to put on their pair of gloves, and then I'm going to come to help you set up your electrolytic cell. Alright, so let me see how this group is doing. So far good. I'm seeing you have your copper metal as the anode connected to the positive end, very good. And the cathode, good, your coin here connected to the negative terminal. So what you can do, you can use the tape. So we have some tape here. So let me just help them and you all please look. So you're using your tape to help secure your coin in. So while it doesn't have, once it holds, it's not about how the tape, if you find it looking ugly in there, miss. So we're going to put the tape on to hold it in place. Good. So you have your copper anode immersed and your coin as the cathode. Use the tape to secure it neatly onto the beaker, and then what we're going to do, we're going to leave this here for 10 minutes and we will see what happens. So remember, we're trying to keep our fingers crossed that we can electroplate this coin to help Anna and her brother Andrew, because we want Andrew to get a 1 in chemistry, right? Good. Okay, so please leave it 10 minutes and then we will see what happens to our results. Alright, so 10 minutes has passed and this group looks really, really happy. So let's see if we can find out if our experiment worked and if we were able to help Anna and Andrew. So let's remove the tape, holding this in place. And the big moment is here, so we're going to do a reveal. 3, 2, 1. Voila. Wow, so I'm hearing all the oohs and the ahs. So well done. Look at that very, very beautiful fresh coat of copper metal onto our coin. So well done. You all have successfully copper plated a coin, and you can now save Andrew and Anna. You can help Andrew get his 1 in his chemistry. Excellent job. So kids, we all take out your coins, and I'll pass around and have a look at it and see what how your coin looks. So well done group, excellent work. Alright girls, well done. You all did an excellent job with that experiment and you got the results that we were looking for. So let's take a minute now to discuss the results. Alright, so based on your activity sheet, what did we, so you have to write in for me what you observed. So could somebody tell me, so we had the first one, what was it that we observed and more so at the cartoon? Yes? Good job, Jane. We observed that we had a pinkish brown copper deposit on the coin, which was at our cathode. Now we want to try and analyze the results that we got, and we had to take some time to complete the activity sheet. So we have a table looking like this on the activity sheet, and we want to try and analyze what happened at either of the electrodes. So in terms of redox, if we think back and remember, what happens at our anode? So Shreya, could you tell us? Good job. Oxidation occurs at your anode. So give yourself a finger clap if you got that correct. Then we want to figure out, well, what will happen at the cathode. And this one, too many hands going up because it's super easy. Because if we know oxidation is happening at the anode, what will happen at the cathode? Very good, Elizabeth. We had reduction occurring at our cathode. So remember, when we're doing electrolysis, we need to be able to properly write our redox half equations. So could I get some volunteers then to write and to tell us what, or to call out for me, what is your redox half equation for the process that occurred in the experiment we did at the copper anode? So I'm seeing many volunteers. Okay, yes. Alina, could you call out your equation for us? So do you all agree with her? Good job. So at our anode in this experiment, remember this was an active copper anode. The anode ionized and we got copper solid ionizing by using electrons to form copper 2+ ions. Excellent job. So now let's see if we can figure out what would have happened at our cathode. So again, many hands. I'm happy to see so many of us want to answer. Okay, so Priya, could you call out your equation? Do we agree with that equation, girls? Great job. So at our cathode, we had reduction. So this was what happened at the coin. Remember that pink brown deposit. This is showing how we got the pink brown deposit. So the copper 2+ ions gain electrons to form copper solid, which is your pinkish brown copper being deposited onto our coin. Well done. So based on what we did in the experiment and what we've learned so far, we want to now try and come up with a definition for the term electroplating. So it's a big word, but if we think about the word itself and if we think about the process that occurred today, we can find that definition. So I'm giving you a couple seconds to think. You can discuss it with your partners. And could I ask somebody to share now, please? Serafina? Okay, so do we agree with that definition, class? Somebody wants to help refine the definition a little bit? So she said something, a metal is being deposited onto an electrode, but could we specify then which electrode? Good job. So electroplating, we can define it as a process where metal is deposited onto the surface at the cathode via the process of electrolysis. Now, I want to ask you, so we did the experiment and we spoke about it. How do you all think is this process of electroplating important to us? So in our example, we copper plated a coin, but think about it on a broader scale. Think about other metals apart from copper. How do you all think that electroplating is important to us? So think about it, and I'm seeing a couple hands, so let me ask. Yes, go ahead. Shweta? Right, so she is saying in the jewelry industry, very good. So you have gold plated and as she said, silver plated jewelry. Anybody else? Think about cars. Right, very good. Car accessories, so you have chrome plated rims on your vehicles. And could I get one more? Think, so let me give you a clue. Think about in your kitchen cupboards. You have lots of this in your kitchen cupboards. So she's saying the cans, yes, but you're looking uncertain. So I'll help you. Yes, canning. So you all know what we do. Those cans coated with tin metal to help prevent it from rusting. So very good in the canning industry as well. So electroplating is important to us through jewelry, car accessories, canning of processed foods, and it can also help to prevent the oxidation or the rusting of other metals. You electroplate it with a more stable metal. So right at this point, I want you to pay attention to this video. So we're just holding on a couple minutes for it to go ahead.
In this video, we're going to learn about electroplating. Electroplating is the process of coating one metal object with another. It works by electrolysis, which is when electricity is used to drive a chemical reaction. We're going to look at why we want to electroplate, how it works, and various conditions that need to be considered. So why would we want to do electroplating? Metals may be electroplated for aesthetics, protection, or both. Aesthetics might involve making a metal shinier or giving it an attractive colour by coating. For example, jewellery is often plated with gold or silver. A metal coating can be used for protection, as it may help resist corrosion, rusting, or just general wear and tear. Car rims are electroplated for both shininess and protection. Chromium, commonly known as chrome, nickel, tin, zinc, and cadmium are often used to plate copper, iron, and steel objects. Tin cans are actually made of steel that have a thin tin coating. Ed White, the astronaut who made the first American spacewalk in 1965, was wearing a gold-plated visor to protect his eyes from the solar radiation. So how does electroplating work? An electric current is passed through a solution that conducts electricity, called an electrolyte. To create this current, two electrons are dipped into the electrolyte solution and connected to a battery power supply. So we end up with a setup that looks something like this. When the current is turned on, the electrodes gain a charge. The positively charged electrode is called the anode, and the negatively charged electrode is called the cathode. The electrodes in an electrolyte are carefully chosen based upon what metal you are plating with. So if you want to copper plate another metal, you will use a copper-based electrolyte solution and have a copper anode. The copper for the plating comes from the electrolyte solution, which in turn has its stocks replenished by the copper anode. So let's look at copper plating as an example. We want to copper plate some brass. So we have a copper anode, a brass cathode, and a copper-based solution for the electrolyte. So copper sulfate solution. copper sulfate solution contains blue copper ions and colourless sulfate ions. The copper ions are positively charged and so are attracted to the negatively charged brass cathode. The copper ions deposit onto the brass, producing the thin copper plate. The positively charged copper ions gain electrons, which is known as reduction. The sulfate ions are negatively charged and so are attracted to the positively charged copper anode. The current supplied to the anode causes the copper atoms to oxidize, which is lose electrons, and then dissolve into the electrolyte solution. So the copper ions move from the anode to the cathode in the solution, and the electrons move from the anode to the cathode, but along the wire. The copper anode bar gradually dissolves to replenish the copper ions in the electrolyte solution, so the solution stays at the same concentration. If another metal was used at the anode, then the copper sulfate solution would get paler or less concentrated. So just remember that oxidation, the loss of electrons, takes place at the anode, and reduction, the gain of electrons, takes place at the cathode. So a few other things to consider in electroplating. The speed at which electroplating occurs depends only upon the strength of the electric current. A stronger current increases the speed at which the ions and electrons move through the circuit, speeding up the plating process. One way to increase the current is by increasing the concentration of ions in the solution. It is also important to choose your metals carefully for electroplating. Not all metals will alloy with each other. For example, steel has to be copper plated and then silver plated because it will not form a direct alloy with silver. There are also environmental concerns associated with some metals. Chrome plating, for example, creates waste materials which are dangerous to humans and animals. Waste products have to be treated accordingly to make sure they are safe, which can be very expensive. And finally, most importantly, for current to flow, the ions need to be able to move. So the compound must be molten or dissolved in a solution. So in conclusion, from this video, you should understand how electroplating works using electrolysis. When the current flows, the positive ions in the electrolyte solution move towards the negative cathode, where they gain electrons, which is reduction. And this is what causes the plating to occur. At the anode, the current causes the metal atoms to lose electrons and dissolve into the electrolyte solution. The electrons, which the metal atoms lose, flow back to the power source and around to the cathode. Losing electrons at the anode is known as oxidation. So just remember, we have reduction at the cathode and oxidation at the anode, and that's electroplating.
Okay, so any questions based on our video? So based on that, then no questions. Good. So we have an appreciation for what is this process called electroplating. So since you all have no questions for me, then I have an assessment for you to do. So thank you for paying attention, and I saw you all enjoyed your experiment today. Good job, and the good news is you were able to help Anna and Andrew. So well done, girls. Please complete your activity 2, and on your way out you can